Good afternoon for those that are starting to see us now. My name's Jordan Parham, Strategic Initiatives and Partnerships Director in HILT CRC. Welcome to today's webinar. We're just going to hold for a couple of minutes while we allow people to come in before we get proceedings underway. All right, it looks like numbers have levelled off but still steadily changing, but we might get proceedings underway. So it's welcome to today's webinar, which is from the Aluminium Stewardship Initiative, the ASI Method to support aluminium decarbonisation. As I said, my name is Jordan Parham, Strategic Initiatives and Partnerships Director in HILT CRC. I'd like to begin today by acknowledging that we are on the traditional, or at least I am, on the traditional owners of the land on which I'm situated today, the Kaurna people, and offer my respect to their spiritual relationship with this country, and acknowledge the Kaurna people as the custodians of the Adelaide region. Their cultural and heritage beliefs are still as important to the living Kaurna people today. So today the agenda is to go through, starting off with Chris Bayliss from ASI, is going to run us through the ASI method. We're going to then cut to Associate Professor Emma Aisbett from the ANU to give a perspective on that. Unfortunately, Emma has to then leave at that point, so we'll take a few minutes for some questions from Emma before we then go to Adrian from Rio Tinto Aluminium to also provide us with an industry perspective. If you do have questions along the way, please do enter them into the Q&A chat, and then I'll facilitate a Q&A session at the end, as well as that immediately following Emma's talk. But first, I'd like to hand over to Chris from the Aluminium Stewardship Initiative to speak. Chris joined ASI in May 2021 as the Director of Standards and has been the Climate Change and Decarbonisation Director since March 2024, and is responsible for leading ASI's climate change and decarbonisation agenda, including through the development and delivery of standards, guidance, tools and advice for members. He represents ASI in external and partnership initiatives. Sounds pretty similar to my title or role there, related to climate change mitigation and adaptation, greenhouse gas emissions accounting and reduction, product carbon footprinting, and science-based target setting. He has 20 years of experience in sustainability of the aluminium sector, leading the development and implementation of science-based approaches to emissions reduction, among other programs. Over to you, Chris.
Thanks very much, Jordan. Thanks very much as well to HILT CRC for the invitation to present today and to be part of this webinar. That's a complex introduction about kind of who I am and what I do. And I could simplify that by saying my job is to kind of show the way that entities need to decarbonize and then to try and get them to do that, or at least give them the tools to be able to do that. That's a bit like the work that we've been doing within ASI, is how do you turn this complexity of emissions reduction against a 1.5 degree aligned future and turn that into pretty simple targets, albeit very difficult to achieve. ASI, we are a sustainability standard setting and certification body, 10 years old now. And we have certifying members all the way along the aluminium value chain. So our membership and those certifying against our performance standard and chain of custody standard are involved in aluminium production and consumption, all the way from bauxite mining through alumina refining and smelting into the midstream semi-fabrication and even into the downstream and a whole host of industrial users who are consuming aluminium, and the recycling flow as well. And our greenhouse gas related criteria within the standard are actually applicable to all of those players. So whether you're a bauxite miner, whether you're primary producer integrated, if you're a rolling mill, if you're a automotive company who is using aluminum parts, criterion 5.3 within our performance standard, which is the one related to emissions target setting and then emissions reduction, applies to you. So this is interesting because it's not just about where the emissions are emitted themselves, it's also about how they're carried through in products as well. So as I talk today, bear in mind that this criterion actually has different drivers for different folks along the value chain. The aluminium sector today emits around 1.2 billion tons of CO2 equivalent. That's about 4% of global CO2 emissions. So the aluminium sector is a pretty heavy emitter compared to many. And of those 1.2 billion tons, the primary industry, so that's from bauxite mining all the way through to smelting, is responsible for about 1.1 billion tons of that. So the majority of emissions, the vast majority, is emitted in that primary phase, but that then flows downstream to the consumers, the users of that material. And so while there are drivers on the upstream to decarbonize, and they are mainly related to energy transformation for smelting, electricity source of power, as well as direct emissions, which will require novel technology development. For the downstream, it's about procurement. It's about low carbon procurement and driving change by preferentially purchasing lower carbon aluminum. The issue is today, we just don't have enough of that, and it's not changing maybe quick enough for them to do that. So we kind of see a shifting of emissions around the system, allocated, accounted for emissions, but is the change actually happening? Actually, the truth is, yes, it kind of is. There has been a reduction in the last 2 years in the total emissions of the industry as a whole. It's driven by the movement of industry in China, essentially from coal-fired regions to hydropowered regions. It's a physical movement of industry. So our criterion 5.3 says that no matter where you sit on the value chain, you need to have defined a 1.5 degree aligned slope, emissions reduction target, and demonstrate performance against that slope. As I mentioned, that 1.1 billion tons emitted today, under a 1.5 degree scenario, that 1.1 billion tons by 2050 needs to be around 50 million tons. So the sector has to reduce its total emissions down by over 95%, even as demand increases for the material. That's a pretty challenging trajectory. This is data that's flowed from the International Aluminium Institute, which in turn is broadly aligned with the IEA, International Energy Agency's net zero emissions scenario. It says that the aluminium sector, that 4% of emissions today, 1.1 billion tons, it has a budget, a carbon budget, that is around 15 billion tons of CO2 out to mid-century. So the industry has 15 billion tons of CO2 to spend. We emit 1 billion tons a year. The IEA baseline was in 2018, I think, 2018. So we've had 7 years of emissions of around 1 billion tons since that date. So that 15 billion tons is today probably about 8 billion tons. That budget is being drawn down as we emit. So the ASI method, the method that we assign to entities, our certifying members, to project this emissions trajectory, it really allocates that budget essentially to different actors. And it says no matter where you start from, you have a trajectory to decarbonize. That's a quite inclusive approach from ASI. It says that we recognize that there is a real range of performance in the baseline year today. And that is really dependent on where you are in the world and the access you have to on the primary side anyway, to certain power sources. It's a function of your location. So the lowest emitting smelters today, around 4 tons of CO2 per ton of aluminium. The difference between them and the highest emitters at 20-something is that the 20-something tons per ton are based in coal-fired regions, and the 4 tons per ton have access to decarbonised power already. And for the downstream, well, they all want access to that 4 tons per ton aluminium, right? Well, today of the 70-odd million tons of primary production, only about 15 million tons is in that low carbon bucket. So there's a limited amount for the downstream to pull through. The ASI method says no matter where you are on the chain, the emissions cradle to gate, that is from bauxite mining all the way through to your position in the chain and including the recycling flow, that intensity of emissions, you have to plot that, how you're emitting today, and then plot forward a curve for your emissions in the future. And essentially the ASI method is what we call a sectoral decarbonisation approach. It is an intensity-based method, so it's tons of CO2 per ton of production or consumption for the downstream. And essentially it converges on a 2050 target that would deliver that 50 million tons from 1.1 billion tons today. And the curve I'm showing you here, this is for smelting essentially. So it doesn't include any recycled content. This is just a smelter bit. And you can see this range of performance in the baseline year with the sector average shown in red and this convergence on 2050. And what you can also see is that everyone has to decarbonize. Even those at the 4 tons per ton, the lowest emitters today, cradle to gate, that number, even they will have to come down to under 1 ton per ton by mid-century. And you can see even in these early years to 2025, when the slope is, sorry, to 2030, where the slope is, it's not gentle, it's quite challenging, not as challenging as post 2030. Even up to that time frame, those low emitters today have some work to do to decarbonize. But what it also says is that really this is agnostic to where you start from. You know, this is not a threshold value that says you must emit below a certain level. This is a forward-looking approach that says you have to plot where you are today. It gives you a curve for the future and the tools that enable you to see how you're going to do that. And the tools essentially for the higher emitters is decarbonisation of power in the early years. It's grid connection and some energy efficiency, although to be honest, energy efficiency is not really the driver for whole-scale change here. Post 2030, it's novel technologies. It will be inert anodes, carbon capture, utilization and storage, alumina refining technologies, electrification, vapor phase recompression, these kind of things. We at ASI are agnostic to the tools that, or the drivers that entities use. We don't say you have to decarbonize in a certain way. Our method just says this is what your slope looks like and you have to measure your performance against this. Now we recognize that there's step change. You know, when you grid connect as let's say a stranded coal-fired entity, your emissions are suddenly going to drop. It's not as smooth as this, but our standard itself says in general you need to be keeping yourself at or below your entity specific line here. Now, is that happening? Well, interestingly, the red line, the sector average, which was the projected number from the International Aluminium Institute, which took that budget from IEA and it took some demand assumptions and plotted this kind of industry average into the future. To be honest, the industry is actually following pretty closely that red line. You know, we were about 16 tons per ton in the middle of the last decade, and today we're about, I think it's about 13, 14 tons per ton. So there is reduction happening in that average. But as I mentioned before, the driver for that isn't that everyone is following this nice slope. It's that a couple of big smelters, coal-fired smelters in China, in Shandong, have moved essentially physically to hydropowered regions. So those two large-scale entities or 2 or 3 large-scale entities that represent a large chunk of the emissions essentially have shifted. There has been a kind of a step change. That's really what we're going to see. That is what's going to drive the change, is these kind of bigger step changes. But the SDA, the sectoral decarbonisation approach, says that it's an intensity based. Everyone has these lines. Now, there are other frameworks available, Science-Based Targets Initiative, for instance, which some of our downstream members are quite keen to leverage because they tend to be not pure aluminium players. They're using a whole range of different materials, different products. But the aluminium sector, certainly the primary sector, was demanding this intensity-based approach rather than a absolute emissions reduction, science-based targets type approach, because of this ability to grow, to meet demand into the future and have curves defined based on intensity. So that's where we are. I have a couple of minutes left just to say that all of the method, and there's some kind of complexity behind the simple curves, is available on our website, multiple languages, along with the method itself. So do take a look there. I think probably this will be shared afterwards for folk to go and have and explore. Interestingly, as I mentioned, we demand that entities set these targets, set these slopes, and then demonstrate performance against it. That's the difficult bit. And what we've seen and what we expect to happen over the next 5 years or so is that most of at least our primary producers will not be able to demonstrate performance in line with these 1.5 degree curves. And I don't just mean the high emitters in baseline year. In fact, they have, if anything, more opportunity to demonstrate reduction because of the potential in renewable energy to quickly shift, whereas those at the bottom end have to wait for novel technologies to mature. So we expect to see up to 90%, 90% of our upstream entities actually non-conformant because of a structural inability to follow the curves. Now, this is going to be addressed in our next version of the performance standard. We're currently going through a revision process. I've got a couple of slides on that, but I'm running out of time. So do get involved in that revision process as we refine in the future our criteria. But essentially at the moment, what we say is that we recognize these structural challenges for entities to decarbonize. And so we have an exemption process in place to allow repeated non-conformances, but still in a transparent way. You have to demonstrate you're doing something. And that's, I expect, what will happen in our next version of our performance standard, is that 1.5 degree alignment, still the ambition, but there will be measures, differentiated measures of performance against that. One final thing to note is that we have a second kind of a legacy criterion in our standard, which is a threshold value that says that by 2030, essentially, any ASI certifying entity that has a smelter within it, those smelters should be below 11 tons per ton. Now, that's essentially based on that sectoral average number by 2030, and it is broadly, it is, I wouldn't say designed, but it has the effect of excluding coal-fired power from ASI certification. And there's a kind of a and that's based really on legacy. That's a legacy criterion, and it's based on your legacy power structure. And here we can see a bit of a disconnect between our two climate-related criteria. You know, our 5.3, the pathways that says you articulate these slopes in the future, it says that, let's say for a high emitter, a 25 tons per ton emitter, they'd have to be at 18 by 2030 to be conformant following their slope. But our threshold says, no, you've got to be 11 whatever happens. So there's this disconnect where you see a forward-looking approach that says map your future using the SDA and then perform against that, versus a legacy criterion that says, no, you must be below this level or you don't meet our standard. That's a tension within our current standard. It's a tension that's ongoing in the discussions for the revised performance standard as well. And it's a tension that is also being played out in the market, right? It's a tension that says, oh, maybe there should be an exclusion of certain parts of the industry as opposed to a driving of change, which is actually ASI's theory of change, is that you map this future and then using our standards, you drive that change into the future. So it's a tension there. I don't have the answer, and we'll see how the discussions go in the next phase as well. Maybe on that point is just to say that we're about to launch a public consultation of a zero draft for the next version of our performance standard in early 2026, and this is out towards a 2027 publication of that new version. There'll be 2 public consultation periods. Do get involved. There is a kind of a revision hub on our website. Go to the ASI website and click on that, and you can get involved both through public consultation but also through other consultations as well. Looking at the time, I think that's just about me with my 20 minutes. More than happy to take any questions, either on the kind of complexity going into this, but also maybe on some of the political or more structural implications as well. But my final thought for you today is to say that the ASI method currently is applicable to players all the way along the aluminium value chain. It's an intensity-based approach for the producers on the upstream, but also for the consumers on the downstream. And it is likely to see repeated non-conformances because of structural barriers to the achievement of those targets. And that's about it. I'll pass back to you, Jordan.
Right. Thanks very much, Chris. I'm sure there are plenty of questions on that. Just ask people to put them in the chat for now. In the interests of time and Emma's competing commitments, we'll just throw straight to her. So just to briefly introduce Associate Professor Emma Aisbert from the Australian National University, who is leading HILT project RP3006 on certification and verification to enable a successful low carbon transition for heavy industry, and is also at the College of Law in the Governance Policy and Associate Director, and as part of the ANU Zero Carbon Energy for the Asia Pacific. Over to you, Emma.
Thanks very much, Jordan, and thanks, Chris, for being so timely and doing a great job presenting. I just was asked to sort of bring some thoughts from the perspective of the work we've been doing in HILT and more broadly here at the ANU on accounting and verification and certification of embedded emissions in products. ASI and its method is, a fabulous example of what we study being put into practice. So I think there are a lot of strengths to the ASI method. I think, it's actually a really kind of leading initiative. It's science-based, 1.5 degrees aligned. That's, a lot of countries, NDCs, for example, can't say that. It's sector-wide ambition and allowing for the heterogeneity of starting points. It takes a modular approach to accounting boundaries, which gives it that flexibility to work all along the supply chain, as Chris mentioned. So it gives clear guidance. So I went and checked out the website. They've got fabulous sort of guidance documents, spreadsheets to plug in and figure out where you're at already. And importantly, of course, third-party auditing, which is really key to legitimacy for certification schemes. And I think Chris rightly sort of emphasised that the heterogeneity, but also the fact that they've managed to find a way really to try and bring the whole industry along together. And that, given the heterogeneity that's sort of evident in the graphs, is no mean feat. And I think ASI should be really proud of their innovative approach to how to make that happen. So there's they have some formulas in the background that Chris hasn't shared, but it really is about everyone doing their share, essentially, and proportional decreases in emissions over time. And so in absolute terms, of course, the currently high emitters need to do more, which also, seems to be about as good compromise as I've seen anywhere in terms of fairness and bringing the whole industry along with you. And so that's really, I think, to be applauded. The challenges Chris also mentioned, and that number one is that so many of the players, and this is not only, of course, in the aluminium sector, we see this in many different sectors, are actually finding that they might not be able to keep their certification. I think on your website, Chris said about 90% of currently certified facilities are at risk of losing their certification on the basis of not being able to keep up with that sort of decarbonisation pathway. Acknowledging once again these structural barriers, the importance particularly for those smelting facilities of being able to access low carbon electricity. And so, of course, the proposal to allow these exemptions, which it's not entirely self-evident that you get the exemptions, but go through the right steps and you can get the exemptions, which of course leads to challenges, right? So in terms of downstream consumers and consumers may be wanting to preferentially buy certified product, or maybe even willing to pay a premium for certified product, may start to worry that that certified product is actually not able to demonstrate that it's decarbonising in a timely manner. So I think, as I said, this is a problem more broadly. So we see similar issues in the iron and steel sector, where there have been sort of ambitious initiatives, some of them like the IDDI and so on, Mission Possible, trying to drive demand for near zero emissions iron and steel, and the industry saying we can't meet that demand yet, and then pressures to sort of find ways around that, potentially to sort of water down or find ways to maybe use offsets or insets to make things look a bit cleaner, to make product look a bit cleaner. So this is, I think, a structural problem. I think Chris is going to have great responses for you in a discussion I'm sadly going to miss. But my initial training is in economics, and I think one of the issues here, of course, is that there is only so much demand globally that is willing to pay that green premium, that quite substantial green premium that you need to achieve those step changes. Like it's quite impressive, actually. Those big Chinese smelters are literally picking up and moving location. But lucky for them, there was hydropower that they could access, right? Not everyone even has that. So these are, if you've got to move from that upper end rapidly down, it's expensive. You need major investments, and potentially that needs to be supported or driven by people, consumers, other sort of customers willing to pay really a substantial premium. And if there's only sort of 10% of the market willing to pay that premium, and you're trying to decarbonize the entire sector, then you have this sort of mismatch between supply and demand. And I think that is sort of a structural problem that faces a lot of these sort of sector-wide decarbonisation initiatives. So that's my sort of provocative upshot. I will say, however, I think in terms of how you're going to respond to that, I think the ASI's current approach of not trying to go in the back end and change some details in the accounting that maybe most people won't notice and take an untransparent approach, but the way ASI have been very upfront and transparent and saying, no, we're going to keep our accounting gold standard, and we're just going to sort of be quite transparent that we're going to allow people a couple of extra years to get on track here. So kudos for that as well. And I'll leave it at that. And yeah, happy to take a couple of questions before I have to run off. Apologies.
Thanks very much for that, Emma. If there's any questions from the audience, please put them in the Q&A chat. In the meantime, Chris, I was wondering if there's any, would you like to comment or reflect back on any of Emma's points there, especially that that closing slide there?
Sure thing. It's kind of interesting. I mean, I was used to be with the International Aluminium Institute. We did some work looking at what the cost of this reduction would be to get down this 1.1 to 50 million ton. And just for the energetic piece alone, the electricity, it was about $1 trillion was kind of that kind of investment was what was required to drive that shift. And where does that $1 trillion need to be deployed? Well, that's just on the electricity, as I say, but then there's a whole heap of work going on in anodes and others ongoing until 2030 and beyond to deliver that. Where's it going to be deployed? Well, the truth is it's going to be deployed at the higher emitters. And the green premium today, an attraction of the green premium today, or I would say people willing to pay for low carbon, kind of paying for what happened in the 20th century. You're paying for a legacy of hydropower that folks are kind of lucky enough to be sitting on in certain regions of the world. And that $1 trillion actually has to be deployed at the 25 tons per ton. You know, if we look at that spread, that 1.1 billion tons, I think there's about 220 smelters in the world today. I think you could probably say that 90% of that 1.1, of the smelter bit of that 1.1 is probably from 40 or 50 smelters in the world. You know, the emissions are concentrated, and that's the interesting disconnect between a very I guess heterogeneous consumer base that's willing to pay, but also quite concentrated upstream. It's going to be whole-scale change of these few facilities with enough push, governmental push and others to go there. Which is one interesting point on that Emma said about the Chinese being lucky enough to have hydropower. Well, unfortunately, these smelters that have moved to those hydropower regions are kind of starved of rainfall because of climate change, and so you're seeing some of those smelters grid connected as well and not using 100% hydropower. So in all of this, we also have to be thinking a bit about adaptation, but maybe that's for another webinar. Yeah.
Okay.
Emma, would you, I'm not sure how much time you have. We don't have any questions coming through, but if you would like, if there's any follow-up you'd like to make to that, go for it. Otherwise, thanks very much for joining us.
Yeah, great. And thanks for the response, Chris. I think, you know, previously when we were chatting beforehand, just to really highlight, I think as you have that this isn't going to happen purely through demand side pull, that we do need that push and we need all of the above. I think that's a great response. And so, as you say, maybe that's really, even though that demand side pull isn't going to really line up with a whole of sector sort of certification scheme, your scheme does potentially really help with that push side of things. So I think that was a great response.
Great. Thanks, Emma. Thanks for being able to squeeze your time in. We'll now let you go off to your other engagement and now move to Adrian Mullins from Rio Tinto Aluminium to get an industry perspective. Adrian is an industrial chemist with a background in Bayer process-focused R&D and is currently Principal Advisor Sustainability, supporting Pacific operations in meeting ASI and other commercial sustainability certifications and navigating the continuously evolving landscape of ESG accreditation. Over to you, Adrian.
Thank you, Jordan, and thank you, Emma. Thank you, Chris, for setting the stage. I'll share my screen. Hopefully everything continues going well. Don't want to derail the good technology that's been coming through so far. So that's sharing. Okay, so I'll just quickly, my teams always need to throw things up like this. I'm not going to read through all this, but just with Rio disclosing any small amount of information, need to have a bit of a disclaimer. And just very quickly, I'll pull out the point. Some of the information in this presentation is forward-looking statements around our decarbonisation journey, and there's known and unknown risks within that, and which may cause the actual results of what is planned to not specifically achieve. And also the other point here is that the information within this presentation shouldn't be transcribed, distributed, reproduced in any other form without approval. But I will get on to the actual pieces I wanted to talk about. So I wanted to go through, before talking about the ASI specific aspects that we've been considering, I just wanted to touch quickly on Rio Tinto's decarbonisation targets and our progress against those targets so far to date. And to highlight that Rio Tinto obviously has several different product groups, and if anybody's been keeping track of the media, we've had a bit of a shake-up. It's actually Rio Tinto Aluminium and Lithium now coming into the same product group, but we look at decarbonisation more holistically for the Rio Tinto group. So our performance within the 2024 period, our Scope 1 and Scope 2 emissions was about 30.7 million tonnes of CO2 equivalent. That's about 14% less than our 2018 baseline of 35.7 million tonnes, and it is the best performing year that we've had to date. So similar to what Chris was noting, of there is observed decarbonisation happening in industry. Rio Tinto is fairly proud that we are contributing to that, and there's a lot of projects being delivered and still underway in the pipeline at the moment. Our Scope 3 emissions, roughly 575 million tonnes CO2 equivalents. They are primarily from our downstream customer processing of our iron ore, as well as our bauxite and alumina products. The piece I wanted to sort of put here was aluminium on the right there. So the aluminium contribution to Rio Tinto's overall Scope 1 and Scope 2 emissions is really quite substantial. So the 23.7 million tonnes that Rio Tinto Aluminium contributes is roughly 77 to 78% of Rio's total emissions profile. So within our total Scope 1, Scope 2, the main contributors are electricity generation on sites and purchase, consumption of carbon anodes within our aluminium smelters, fossil fuels within our processing, and then diesel consumption within our mobile equipment, mobile mining equipment. So aluminium really does have a large focus, even though we generally talk about our decarbonisation as the Rio Tinto group. Aluminium really has the biggest part to play within our Scope 1 and Scope 2 decarbonisation journey. And as far as our targets, it's very well aligned with, I guess, global net zero by 2050 and a 50% reduction by 2030. So what I'll show now is our decarbonisation pathway. So this is not yet talking about the ASI pathway. This is our Rio Tinto group decarbonisation pathway. So I'm still sort of setting the scene here a little bit. But Rio Tinto group look at the abatement areas of action. So on the right there, we're breaking things down into our primary areas: renewable energy, diesel use, minerals processing, and then alumina refining and aluminium anodes kind of fall within the minerals processing section. However, they're called out individually because they are large contributors and they are hard to abate, so they have their own called out area of action. And nature-based solutions called out there as abatement projects continue to complement the investment that's happening for the other areas, and seeking purchasing of high quality carbon credits is part of our overall strategy. Our actual decarbonisation pathway, we have a 2018 baseline, and so you can see there where we are currently sitting at the end of 2024, and the trajectory is obviously not linear, and is dependent on when our projects are planning to be delivered. And similar to what Chris noted, there's going to be a fairly sharp drop planned around that 2030 period when some of our repowering, so the BSL, so BSL is Boyne Smelters Limited, is one of our aluminium smelters in Gladstone in Queensland, Australia, and it is one of our key decarbonisation projects for the Rio Tinto Pacific operations with aluminium. A few other, I guess, call out specific within Rio Tinto Aluminium in Australia. as well as globally. So there's the BSL repowering. There's also hydrogen calcination project, which is ongoing at the Yarwun Alumina Refinery in Gladstone. There's double digestion project at the Queensland Alumina Limited refinery in Gladstone as well. And then one of the other big ticket R&D projects is Elysius, which is a joint venture with Alcoa for a carbon-free aluminium anode. Before I move on, just noting down the bottom, I do have, I guess, the reference to a few things where there's more information around Rio Tinto holistic as well as the specific product group decarbonisation journeys, and the 2020, all of the data here sort of from the 2024 annual report. So you can go onto our website and find more if interested. Now, I'll talk a little bit about the ASI, and firstly, probably Rio Tinto Aluminium and ASI, and sort of how we've gotten onto the journey with ASI. So Rio Tinto actually participated when ASI was being established in 2012 and supported the process continuing through to when, as Chris noted, ASI has just turned 10 years old, so when ASI was fully established in 2015. Rio Tinto Aluminium were actually the first to receive an ASI certification against their performance standard, and we now have 3 separate certifications for the performance standard globally, and they're regionally defined. So each of our certificates have several of our sites within them. So there's the Canadian operations, the Pacific operations. The ISAL, so the Iceland Aluminium Smelter, is the only one which is a standalone site. We also hold the chain of custody certification with ASI, which is global. Like all of our sites that are ASI performance standard certified are covered in the chain of custody certification, which is a material traceability standard. There is our link to our ASI members page down the bottom there as well. So all of our certifications and the audit reports are available on the ASI website, which is really handy for looking at all of the ASI members. A very transparent process that ASI have in place there. Unfortunately, I don't have the approval yet to disclose what we had for the ASI calculation methodology output, but I wanted to go through, I guess, the considerations that we've been making, and then we've had to make with this methodology and the use of it, and then just a quick note on when we are actually going to be performing our reporting. So the primary considerations for ASI, one of them, level of disclosure. So as I noted, a lot of our decarbonisation and our greenhouse reporting is performed at a Rio Tinto level. However, to satisfy the performance standard for ASI, we need to bring that down a level and look at it at a RTA level, so Rio Tinto Aluminium level. We do this for some of our emissions data, but not all. So that's a further step that we have with our transparency we're seeking to achieve. Another piece is we need to consider how we are incorporating or splitting our ASI sites versus our non-ASI sites within the ASI calculation methodology. So we do still have some aluminium sites globally that aren't within the ASI, and so we can incorporate those in, we can pull them out. We also have joint ventures, non-managed joint ventures of aluminium, where within our normal greenhouse reporting, they are being accounted for on an equity basis. So we're really needing to consider and work with our senior leaders to know, to determine how we want to present the ASI calculation. Considerations with the data. So the ASI methodology relies on our life cycle assessment data, which currently we perform major LCA data calculations every 5 years, which is in line with the International Aluminium Institute's LCA data set, which is released. So we have these for all of our smelters. However, we need to adjust how we're going to be doing that for the purpose of meeting the ASI 5.3 clause. The other point, baseline year, is another heavily consideration. So 2023 is what we've chosen for the baseline for our ASI method. I can't share that, and that's because that was our most recent year of our full LCA data set being completed and externally assured as well. So a lot of confidence in in that data set. Probably the biggest considerations that we've been having internal discussions on is around the messaging for this calculation. So there is already a lot of greenhouse and emissions reporting that Rio Tinto perform, both regulatory reporting as well as public disclosure in our annual reporting suite. What we're doing here with ASI is it's a new calculation methodology, and so we also have a new number, a new greenhouse number that we are reporting publicly. So it's really needing to consider what messaging we're putting with that. I'll just jump to the bottom there. We're really needing to proactively manage, I guess, this understanding with the regulators and with the public and with commercial customers to avoid confusion. For ASI methodology, it's also very cast house centric. So our certification spans mining, refining, and smelting, and ASI have endeavored to also make the calculation apply throughout the entire value chain, which is no small task. However, for how we generally report our scope 1 and scope 2 emissions, the scope 1 definition within ASI is a bit different. So we're really needing to make sure we're clear with that when we're doing our reporting of this. Our business decarbonisation project delivery pathway is also different to what our calculation is so far with the sectoral ASI sectoral pathway as well. So again, another piece we need to consider with our messaging. And the last point there, I noted on the previous slide, our baseline year for Rio Tinto Group decarbonisation targets is 2018. However, for the ASI methodology, we've chosen 2023 for the purpose of having a good complete set of LCA data. So again, another conflict with the way that we're doing those. So they're all the considerations we've taken into account. Where we are currently, we have done our calculations according to the ASI methodology. Very, very simple tool to use. So noting what Chris said and what Emma said, the tool is online, very simple to follow. There's a flow chart to define how any given entity should perform their calculations. The first calc, easy. The second and subsequent calculations, which need to be done on an annual frequency, we are currently working on what methodology will apply for those interim calculations, considering we won't have updated IAI LCA data. So we're working on that methodology to ensure it's robust and suitable to then have as the subsequent disclosures. Our disclosure for the ASI methodology will be in Q1 next year. We are going to be performing it as a specific additional report rather than incorporating it into our other existing reporting. And the reasoning behind that is it gives us the ability to give that messaging a lot of clarity, and that we can ensure that it's clear what the purpose of it is for, and that it's the ASI methodology and how the entire aluminium industry is needing to progress against it. That's probably everything that I kind of had to go through. So I guess, I'm not sure how I did for time. I wasn't really looking, but
that's okay. It's about perfect. We've got about 10 minutes left for questions. And so thanks very much, Chris, for first covering off the overall framework and methodology, and then Adrian for taking us through a specific example of that. I think that's worked really well. So just a reminder, if you do have a question, please put it into the chat. Maybe that there was one at the start that I know you've put some comments on, Chris, but maybe to draw that out a little bit more. China in all forms of metal processing is significant. And so how do you see that, or like reflecting in that trajectory or those numbers of China and the rest of the world? Do you see is there different regional data sets that you see, or it's aggregated? And yeah, maybe just a bit of a comment on that China, rest of the world, and regional aspects.
Sure thing. And thanks very much, Adrian, for the look under the hood at RTA. And we could do a whole piece on that. It's very interesting. It'd be great to have someone here on the midstream bringing in recycling as well, which adds that whole other layer into the cast house. But just to say that, yeah, that disconnect, or certainly the tension between the ASI method and a whole lot of other reporting frameworks and regulatory is certainly felt by us. And maybe a big message here is that all these emissions calculations are actually emissions estimates. And we, ASI, and everyone should do, I think, a better job of noting what kind of precision is possible. Because to be honest, the 25 tons, I don't care about your decimal place. I don't. The decimal place is it's an uncertainty in the underlying data. And that's true for the Chinese numbers too, right? There's some argument and discussion around which kind of life cycle databases to use. Whichever you use, I'd add a plus or minus 20% in there, right? But what we're looking for is this whole scale change, 25 coming down to 4 and then down to 1. On the Chinese industry side, of course, it's a new industry. There's oft quoted message actually developed to the II. I was there when it was developed. 75% of all aluminium ever produced still in productive use. That's often talked about as a recycling story. It's not. And 75% is about true for all metals. Just aluminium for all metals. But of that 75%, well, aluminium started production late 19th century. I think it's 1.4 billion tons produced since the late 19th century. 800 million tons produced since 2000. So it's not that there's a whole load of material that's been recycled. It's that most of that large aluminium stock in use has been produced in the last 20 years. It's gone into use in long life products in China, among other places. But that Chinese industry is new. It's not a 20th century industrial base that needs to shift. That shift has kind of already happened. So you'd have highly efficient facilities in China. It's just they're in regions of high emitting power, stranded power, essentially. Sorry, I think I went for a minute. What that means, of course, is that China has lots of experience of building smelters, right? You look at outside of China, who is been building greenfield, it's not that many. And the kind of structural shift that has to happen is really a retooling of the sector as a whole. As Adrian showed, this kind of that step change, really interesting for Boyne, that kind of repowering element, essentially a change to the grid. That's, in some respects, China has is more willing to, let's say, move facilities, turn facilities off, not turn them on and leave them for 75 years. You know, these smelters in China are 12 years old, something like that. They're not post-war smelters or 1970s smelters that will require development. So actually, China can drive this change a lot quicker. That's to a point that someone else raised around this rise of let's say, rather than rise in national, I'd say deglobalization. Actually, China is kind of well placed for that, partly because it has a large recycling, a large scrap hump that's going to come back as well. You know, all that material that went into the cities in China is going to come out relatively quickly, and thus access to lower carbon scrap. China is kind of preferentially placed compared to other parts of the world. In terms of use of our method, though, is interesting. Go and take a look at the certs and the audit reports that are online. The Chinese industry is using the ASI method, is reporting against that method, and certainly on the downstream side, the access to lower carbon metal in China is probably, well, it's going to, how can I put this? Of that 15 million tons global low carbon aluminium supply, lowest carbon primary aluminium supply, about a third of that comes from Siberia, comes from the Russian facilities. And while there is self-sanctioning of that lower carbon material, it's going to go somewhere else, and it is tending to go into China. So suddenly you have this lower carbon flow available to Chinese entities that maybe other parts of the world do not have access to, or do not are limiting access to, let's say that. So yeah, that's some of the interesting stuff on China. Also, what we can expect to see is Chinese investment outside of China too, right? So new projects in lower carbon regions. So China is a very important part, of course, of the aluminium sector and all metals, minerals processing sectors. I think, as Fiona said in the chat, they represent 20%, or Chinese headquartered members represent 20% of ASI's membership. So ours is certainly not a standard for the world excluding China. It is a standard for the global aluminium industry that increasingly is deglobalizing. And that's a challenge we'll have to deal with in the revision process for our performance standard.
Thanks, Chris. We've got a few minutes left, and maybe one more question from myself in that is, Adrian, you sort of talked about numbers. There's lots of different numbers that you have to produce as a company for regulatory reasons, also ASI, and I guess this question is also to you, Chris. The ASI method and having that number there gives some, does provide a measure, and I guess to Emma's point, certification and transparency or credibility of numbers is important. So how does maybe you as an industry navigate all these different numbers you need to do? And Chris, as ASI, how do you navigate making sure that the ASI still is meaningful and is a gold standard out there that people sign up to? So maybe if you just get a brief comment from both of you on that, and then we'll wrap things up. Adrian, would you like to go first?
Sure. Assurance, I will say. So there is, so within Australia, our aluminium sites are going through their NGAS assurance audits currently for regulatory reporting of our greenhouse emissions. The data which goes into the ASI calculation is our LCA, life cycle assessment data, which has independent third-party assurance performed on it as well. So for the ASI method, it's good that it's using something which we already performed that assurance on. However, as I noted in my presentation briefly, it's something that we really need to consider. What is our options, and how are we going to go about the annual based reporting as an update? So we, as part of the ASI methodology and criteria requirements, we need to show our progress on an annual basis against our trajectory. And so we need to redo that calculation. So we're needing to consider what our methodology is and how we ensure that that data is robust and of good quality to then put into that public stage. Like we don't take it lightly putting out those values and really ensure that anything that's going out has been tried and tested. And yeah, as I said, assurance. I think a lot of the firms globally that are involved in this are sometimes playing catch up with all of the new methods that are coming out, and CBAM in Europe is probably a good example where there's new assurance required in Europe for their carbon border adjustment mechanism. I think all of the assurance providers are trying to keep up with all of the different regulatory spaces happening. So I think it's a challenge across a fair few aspects of the industry. But yeah, in ASI's case, it's good we can use a base of data which has already gone through that.
Thanks, Adrian. Chris, do you want to have a final comment on that? I'll give you 30
Sure thing.
seconds.
Yeah, no, look, we tried to do that, so they use the base data for lots of different approaches. But here's the thing, is how you carve that up is also really important. So on the one hand, having your entity-wide emissions reduction is one thing, but how you allocate that to your product output, which is the scope 3 category 1 of your customer, that's a tricky bit, because then you're also scoping things differently. That difference between a product level accounting and the corporate accounting is a huge challenge, especially for us as we incorporate the mid and the downstream in that. And you have folks who have, let's say, a mixed power source coming in and maybe don't have a mixed footprint of their products coming out, but allocate lower carbon to certain products going into certain markets. So that's a challenge that we're going to be exploring through the revision process of our standard to maybe focus in different ways, different parts of the value chain. So it's clear the ASI method is well suited for the upstream folk for this kind of life cycle data, but mid and downstream, maybe there's something else that might be required for them, especially those who are using multiple products, including steel, magnesium and things as well. So yeah, it's not going to get any easier. It's going to get more complex, and our job is to somehow, on the one hand, keep that messaging tight, enable entities to use data they already have in hand, but really, and here's the thing, is actually to drive some change. It's not just to do a whole load of accounting and a desk-based exercise, but to bring that 1.1 billion tonnes down to 50 million tonnes over the next 30 years. That's the challenge.
Right, that's a great final note to finish on, Chris, because that is the overall objective, and all the different tools between technology, policy, and things like the ASI method are needed to work towards that. So thanks to you, Chris, for getting up early from London to participate in that. Adrian, thanks for your contribution in her absence. Still like to say thanks to Emma, thanks to everyone for joining us. For those, we do have a future webinars coming up soon, but the main event coming up soon in HILT land is the HILT conference, October 14 and 16. So for those of you that will be there, look forward to catching up in person. Otherwise, to the next event webinar that will be after that. Look forward to seeing you online. Thank you very much, everyone. Goodbye.